Okay, this is for test number 4. The first one I got wrong actually was the multiple choice, but I'm going to do the examples first because that's just the order I did the corrections in. So this is problem number 6, which is an electron has a speed of 3 times 10 to the 6 meters per second in direction perpendicular to a uniform magnetic field, and the electron moves in a circle of radius 0.2 meters. What's the magnitude of the magnetic field? So I use the equation that the magnetic field equals mu naught times charge times the velocity, and then a direction divided by 4 pi r squared. Well, that's obviously wrong. The equation is the magnetic field equals mv over qr, or mass times velocity over charge times radius. So obviously that's what I have up top, mass being 9.11 times 10 to the negative 31 kilograms, velocity being the 3 times 10 to the 6 meters per second, which cancels out with the meters below. Q being the charge is 1.6 times 10 to the negative 19, and then obviously the radius is 0.2, which gives us 8.5 times 10 to the negative 5th Teslas. The next two questions, actually, numbers 9 and 10, were simple calculation errors. They were off by a decimal point. And the reason being for that is mu naught is 1.257 times 10 to the negative 6th. I did 1.257 times 10 to the negative 7. So in both cases that accounted for my being off by a digit. On 9, I had the right direction also of the field. So yeah, kind of sucks. I was just off by 1. Okay, the next couple, I'm just going to do real quick. Number 12. I got wrong the right hand. I just did the right hand rule wrong. The numbers I did okay. It was just the right hand rule being applied inaccurately. I still kind of have a hard time with that. The next one, number 2, 2 parallel wires are near each other and they carry currents in the same direction. Wire 1 carries current 1. Wire 2 carries current 2. Carries current I. Wire 2 carries current 2I. Which statement about the magnetic forces that the 2 wires exert on each other is correct? So, first of all, they're going in the same direction, which means they're going to be attractive. If they were going in opposite directions, then they would be repulsive. So, that automatically gets rid of about half the answers. 2, Newton's third law, all forces are equal and opposite, duh, which leaves B and C. Well, since only one of them is attractive in B or C, it leaves to B. I did G because I'm stupid. And thinking that they have wire 2 is going to have bigger numbers because it has twice the current. Doesn't necessarily apply to force. Number 3, resistors don't have spikes. It said an inductor and a resistor connected in series to a battery. There's a switch that allows the circuit to be opened and closed. At the instant the switch is closed, the voltage drop across the resistor or the inductor maximum. Resistors don't have spikes. So that leaves the inductor, but the reason that the inductor even has a spike to begin with is because inductors oppose the change in current flow. So if the current is flowing and you turn it off, it's going to have a spike to try to get that current flowing again. If the current is not flowing and you turn it on, it's going to have a drop to turn the current off, or try to stop the current from going in the first place. Number 4, the direction of the magnetic force of the proton, and then it gives a diagram. Again, I was having a hard time with the right hand rule. I did it the direction of the velocity of the proton, and then the direction of the north is facing, which gave me into the paper. Well, that's wrong. I should have done it the direction north was facing, and then the direction of the velocity, which would be out of the paper. So I did D because I applied the right hand rule wrong when it should have been C. And that is it for my exam for test corrections. It was mostly multiple choice because that is where I always struggle. Thank you so much.